Okay, lesson 3 is linear equations in X. LEQ, how can I understand the meaning of linear equations in X? Consider the following equation. Which equations are true and how do you know? So go ahead and pause the video and be able to determine which of these equations are true. Okay, welcome back. So hopefully you recognize that 4 plus 1 is 5. That one's correct. This one is not correct. And then 21 minus 6 does equal 15, but 6 minus 2 does not equal 1. Okay, so before we get started, just want to let you know as far as learning adding and subtracting and dividing numbers, we started off with probably like in first grade where you had a box plus a number equaling a number. Okay. And then you had to figure out what that number was. And then, which is 3. So then you go ahead along, and now that box is replaced with a line plus 2 equals 3. Okay, and now all the way up to 8th grade, we're just taking that line and substituting it in for a variable, meaning x plus 2 equals 5. Okay, so I just wanted you to see that, to keep that process where we have two terms and it's equaling a number. That's our whole goal, to find that actual number that's missing. Okay, so we want to define linear equations in X. Here are some examples of linear equations. Using what you know about the word linear equation, develop a mathematical definition of linear equation X. Well, looking here at the equations, we can say that two linear equations are equal. They can be written as a linear equation in X. Okay, so that both sides have to be equal. So here we have our definition. As far as a linear equation and X's statement about equality. So both of the sides would have to be balanced. Equations that contain a variable does not have a definitive truth value. The number X is called a solution to that equation. So being that we don't know what X is, well, this one we probably would know that X has to be 4. But for this one here, we would need to figure out what X is. Okay, so for this lesson, we're going to go ahead and try some different solutions to see if that solution makes the equation balance. So this one here, we have 4 plus 15x equals 49. We're going to substitute in 2 for where we see x. So I have 4 plus 15, and I'm going to substitute 2 in, put parentheses because that's multiplying, equals 49. And then we have 4 plus, and then 15 times 2 is 30, equals 49. And 4 plus 30 is 34. And the other side is 49. So since this statement is not true, x equaling 2 is not a solution for this equation. 4 plus 15x equals 49. Okay, let's go ahead and try x equaling 3 for the same equation. So I'm going to have 4 plus 15 times 3 equals 49. And then I have 4 plus 15 times 3, that would be 45, equals 49. 45 plus 4 equals 49. At least that's what 49 on both sides. So that means x equaling 3 is a solution for the equation 4 plus 15x equals 49. Let's go ahead and look at another example. This time they have x equaling 5, and it's for the equation 8x minus 19 equals negative 4 minus 7x. So wherever I see x, I'm going to substitute 5 in. So I have 8 times 5 minus 19. And then negative 4 minus 7 times 5. 8 times 5 is 40, minus 19. And then negative 4 minus 35. Okay, so on my right side, I know that's going to be negative 39. And even without subtracting this, I know that my answer will not be negative. So we have 40 minus 19. That's going to equal 21. So being that 21 does not equal negative 39, x equaling 5 is not a solution for this equation. And that would be the equation 8x minus 19 equals negative 4 minus 7x. Okay, let's try x equaling 1 for that same equation. So I have 8 times 1 minus 19 equals negative 4 minus 7 times 1. So we have 8 minus 19 on the left side, and then negative 4 minus 7 on the right. On the left, we're going to end up with negative 11 equaling negative 11. So that statement is true, which means x equaling 1 is a solution. Okay, so to summarize the lesson, remember both of your expressions have to be equal to one another in order for that value of x to be a solution for that equation.